sklearn, model selection, learning curve display. Description. Learning curve display is a class in scikit-learn that helps visualize the learning curve of a machine learning model. It plots the model's performance, e.g., accuracy, precision as a function of the training set size. This visualization allows you to assess how well the model learns from data, whether the model is overfitting or underfitting, the potential impact of collecting more training data. Inputs. Estimate the machine learning model, e.g., a classifier or regressor whose learning curve you want to visualize. X the input features for training. Y the target labels for training. Train sizes, a list or array of training set sizes to use for generating the learning curve. The values in this list should be between 0.0 and 1.0, representing fractions of the total training data. Scoring, a string or callable object specifying the evaluation metric to use for the learning curve. Common metrics include accuracy, precision, recall, F1 score, etc. CV, an integer or object defining the cross-validation strategy. This controls how the training data is split into training and validation sets during each iteration of the learning curve. Shuffle, whether to shuffle the training data before splitting it. Random state, an integer used to control the random number generator for shuffling. N jobs, the number of parallel jobs to run for cross-validation. Error score, a value to assign to the score if an error occurs during cross-validation. Train size subs, a list or array of absolute training set sizes to use for generating the learning curve. These values are in terms of the number of samples. Axis, matplotlib axis object to draw the plot on. If none, a new figure will be created. Outputs. Plot, a matplotlib plot displaying the learning curve. The plot shows the model's performance on both the training and validation sets for different training set sizes. Fig, the matplotlib figure containing the plot. This allows you to customize the plot further. Steps. Initialize the learning curve display object with the desired model and other parameters. Call the plot method of the object to generate the learning curve plot. Metrics. Training score, the model's performance on the training set, measured using the specified scoring metric. Validation score, the model's performance on the validation set, measured using the specified scoring metric. Visualization plots. Learning curve, a line plot showing the model's training score and validation score for different training set sizes. The plot typically includes error bars indicating the standard deviation of the scores across cross-validation folds. Fine-tune parameters. Train sizes adjust the range and number of training set sizes used to get a more detailed or concise learning curve. CV, modify the cross-validation strategy to control how the data is split for evaluation. Scoring, select a metric that is relevant to the specific task or problem being addressed. N jobs, increase the number of parallel jobs to speed up the computation of the learning curve. Uncertainty methods. Error bars, the learning curve display automatically generates error bars on the plot, showing the standard deviation of the scores across cross-validation folds. This provides a measure of the uncertainty in the performance estimates. Challenges and fixes. Challenge 1, learning curve is too noisy or erratic. Sample use case that resulted in challenge 1 using a small number of training set sizes or a low number of cross-validation folds. Fixes to challenge 1. Increase the number of training set sizes used to generate the curve. Increase the number of cross-validation folds to reduce the variance in the performance estimates. Challenge 2, learning curve shows overfitting. Sample use case that resulted in challenge 2, the model performs much better on the training data than on the validation data. suggesting that it is memorizing the training examples rather than generalizing to unseen data. Fixes to challenge 2. Try simpler models with fewer parameters. Use regularization techniques e.g. L1, L2 to prevent overfitting. Challenge 3 learning curve shows underfitting. Sample use case that resulted in challenge 3 the model performs poorly on both the training and validation data, indicating that it is not complex enough to capture the underlying patterns in the data. Fixes to challenge 3. Try more complex models with more parameters. Use feature engineering to create more informative features. Consider collecting more training data. Challenge 4 learning curve is flat or shows no improvement. Sample use case that resulted in challenge 4 the model's performance is not improving as the training set size increases, suggesting that the model has already reached its optimal performance. Fixes to challenge 4. Ensure that the data is properly pre-processed e.g. scaled, standardized. Check for potential issues with the model architecture or hyperparameters. Consider using different evaluation metrics or data splitting strategies.